Hi, this is David Raffoff with another video on game programming, and this time I'm going to be covering a little bit on encapsulation and testing. So coming from my background, which is not working on games, it's mainly working on web applications. One of the things that I was really curious about was how to test code and how to write it in a way that makes it easy to test. I think by default with Unity, the kind of direction you're pushed with most of the code that you start on is to write these mono behaviors that attach to your objects, and they're a little bit trickier to test because you need, the Unity engine, and you're immediately have all this baggage of all the stuff that comes along with a mono behavior. So essentially, I wanted to add an effect to my player here. So I'll just run through this real quick. So when I run into an enemy, I want to take damage and flash. And I'll primarily be focusing on the flashing effect for this. So this was a nice bit of code that was something that could be encapsulated and not part of the mono behavior, and there were a few things I had to do to make that possible, and also to test it. So I just wanted to run through some of that now. I'm actually really new to writing tests in Unity, so just wanted to quickly point out kind of where you can get started with that. So there's a window here for test runner, and when you open that up, it'll launch in kind of its own separate little floating window, but you can pull it into any of your other panels that you have, and you're going to see something that looks like this. I think by default the tests, most of the tests that I've been writing have fallen into edit mode. I'm not sure what the play mode tests are for, but when you're in edit mode, when you open this up for the first time, there'll be an option that'll let you just essentially generate the your first test for you, and then you can go in and kind of fill it out. So you can see here I've got one test in here for this thing called attribute, and then I've got a bunch of tests in here for the flasher effect. Probably want to call that like blinker eventually, but anyway, you can also run your test here from this run all button, or you can pick the one that you're interested in and just run that one. As you're adding tests too, you'll see them you'll see this window update, and it'll get a little circle next to ones that haven't run, so it'll look actually kind of like this one up here. So anyway, that's just kind of the general layout of where to find things. So I'm going to switch over to the actual code for this. So just to show you how this is getting used first, so I have a hit reaction mono behavior that's attached to the player. If I switch over here to the hierarchy, you'll see in my scene I have a player, and that player down here has a hit reaction, and that hit reaction has a delay amount and a total number of flashes, and I'm using those values over here. So in hit reaction, I'm going to have a flasher, which is conforms to an effect interface that I wrote, which is nothing fancy. I can show you that in a bit. But in my start, I basically just set up a new flasher using those two values that we were looking at in the inspector. So by default, the delay is going to be 3, and the total number of flashes is going to be 5. But whatever is set in that will get passed in here. And then the way I'm using it is in the fixed update method, which is one of the lifecycle methods for mono behaviors that guarantees like a regular interval. And that we're going to check to see if the flasher effect is running, and if it is running, we're going to update it, and then we're going to look to see what the value of the flasher is, and then if this is visible value is going to get set for the renderer is going to use that. So basically, like there's a sprite render on the player character, and if it's enabled, you're going to see the character. If it's not enabled, you're not going to see the character. So This is very maybe oversimplified example, but I think it still works to kind of illustrate how to set this up. So essentially, if the flasher is running, we're going to do an update, and as it kind of flashes on and off, we're going to be setting we're going to be turning the sprite renderer on and off, and then to fire it off, we have this on collision enter 2D. So we have a 2D box collider set up, and when it runs into something, it's just going to start the flasher. So again, this is a little simplistic. The flasher will get fired for any kind of collision, which is something that I still need to clean up, but just for the purposes of showing this, I think it's probably good enough. So if we hop over to the flash effect, I'm just going to kind of quickly run through it. So the way it works is we basically want to flash for, say, like 5 times. So we need to keep track of that, and then we need to keep track of how many times we've done flashes, or I'm actually calling them partial flashes because it's both an off and an on, and we don't want to flash on every single update. So what delay does is it basically waits until a certain number of calls have been made to do the effect. So the bigger the delay is, the longer it'll take for each flash to happen. And then the counter just keeps track of like how many of those updates have been done. So nothing too crazy here. This is that start method that was being called from the collision. And all it does is say if it's not running already, go ahead and start it. And then this is the update method that will be called on every update of the mono behavior, or every fixed update of the mono behavior. And there's just basically a bunch of things here to make it stop early. So if it's not running, it just goes ahead and returns. It gets out of here. If the current count of the partial flashes is equal to the total partial flashes we're done. So in that case, just going to reset all those like counter values and get out of here. And then otherwise, if counter is 0, we're going to go ahead and do the flash. And there's a couple of ways you could approach that. You could wait for the counter to get up to the first delay and have that be when it happens, or you could just do it immediately when it's at 0. The effect looks better if you start just immediately. Otherwise, it feels like it takes a little too long. It feels a little disconnected from the action, so the kind of instant feedback is nice. And then if we get through all of that, we just want to increment the counter so that next time we come into the update, things have progressed, and we can compare to see how many iterations we've done. Basically, there's a little bit of additional logic here in increment counter. So we want to count up, but we also don't want to like exceed the delay. So we're just doing a modulus here for the delay to make sure it never exceeds that. So if your delay is 3, it's going to go 0, 1, 2, 0, 1, 2, I guess, and start over, or 0, 1, 2, 3 and start over. And then in Flash, all we're really doing here is it's super simple. We're keeping a track of this flag for whether things should be visible or not. And then in Flash, all we do is toggle it. And then we count up the number of partial flashes we've done, because remember, Flash has 2 parts. So it's got the turning it off and turning it on. And then finally, we have a reset. So, after this is totally done, after we've done, say, like 5 flashes, we'll come back in here and just reset the effect. So we'll set visible back to true. We'll say it's not running. There's no current partial flashes count. That's just 0, and same thing for the counter. So it's just starting everything over with the initial values. And there's probably there's different ways you could approach some of that too. You could basically throw away the flasher when you're done, and then just instantiate a new one. But I kind of like doing the reset because I think it's just a little bit more efficient. So you don't have to spin up a new flasher every time. You just can reuse the same one. Especially because you could be, in a really busy game, you could be hitting 4 or 5 enemies within the span of a few seconds. So anyway, that's kind of the way I approach that. And it's worth noting too, for testing purposes, you're only going to test the public methods here. So you notice a lot of these things are private down here. So we're just going to be testing the overall behavior. We don't have to directly test each of these methods, just the public interface here. So yeah, that's the code that I was writing tests for. And then if we hop over here, I have this file called flashertest. And you'll notice in the editor here, there's kind of a new node over here for the my games editor, and it's got its own tree of folders here. And inside specs, I've made you'll automatically get this assets, specs, and editor folder. Within that, I made a folder for effects because I have a namespace and a folder for my effect. And then here is the flashertest file. So this is just a file that I made. And up here you can see I'm using NUnit, and got this class for the test. Forgive me too, I'm totally new to NUnit, so I probably have some stuff in here that's not done totally correctly, or there's better ways to do it, but just thought I'd run through this for people who are pretty new and kind of wondering how to get set up. So one thing you'll see here is I have this setup tag, and then as you go down the list here, I have tags for like tests above all these methods. So only the things that are tagged this way for test are going to get picked up and run. If you take this off, it just won't even show up in the test runner over here. You won't see it. So if you're wondering why your tests aren't appearing when you're writing them, just make sure you've got that. And then, so basically, I just have a list of tests here. And then there's some comments set up to all of these tests. So I have this tag here for setup, and then a setup method. And all this is really doing is just setting up the kind of basic flasher here. So, I could have made this shorter and just directly passed in values, but I typically like labeling everything that I'm using so that it's clear what it's doing, because ultimately the test should also, they serve multiple functions. One is documentation. One's to help any new developers who are looking at this, or even help yourself in a month if you haven't looked at the code, to come back and quickly understand it. So I always like to just label things super clearly. So anyway, my setup's maybe a little longer than it could be, but it helps me out. And so basically, before each of these tests run, this is all going to be set up now, so I don't have to go through doing this for every single test, and that makes it easier to keep the tests nice and short. There's more of this kind of setup that I would normally do with as we go down the list of tests here. There's some things that start to repeat. I'm not familiar enough with NUnit to dry that up, but if I was using something like RSpec for Ruby, it has a lot of nice tools for handling things like that. So anyway, I'm hoping to learn more about that. If you're familiar with that, just drop some notes in the comments. That'd be super awesome. Also, if you know a good source for a NUnit book, or just kind of quick read to kind of get up to speed on that, that would be great. But yeah, so anyways, we go down the list here, you'll see for each of these tests, we have a method to go along with it, and the method name should kind of explain what the test is about. So in this case, the name of this method is initialization sets is running. So when this thing, when the effects flasher is initialized, this is all that's happened by the time we get here. But because we've already taken care of that, we can just focus on the assertion. So we're asserting that the effect, which I'm just calling subject, is not running. The is running is false. And And then the following test here is just checking the initial state 2 for is visible, making sure that that's true. Because the first time we cycle the flash, we want to go to invisible because the player is already going to be visible. And then the next test here is when we run the start method, it changes is running to true. So another just tip on testing is you want to see that the action you're taking has an effect. So you want to check preconditions. So here I'm checking that, after initialization, that is running as false. Run start on that flasher, and then want to check that is running is true now. If we didn't have this precondition, you don't really have any guarantee that that running start is actually changing the value. You just know that it's true after it's run. Then here on update when this test is update when not running does nothing. So what this is checking for is that if the flasher hasn't been started, we actually don't want the update to have any effect. So again, we're checking this precondition to say that it should be visible, and then we run update again and make sure that it's still visible, so it didn't actually cause anything to change. And then the tests down here start getting a little longer, and this is where I would like to kind of understand NUnit better and see how to dry some of the stuff up. But this test is for update when running immediately changes visibility. So this is kind of a follow-up to this test here. So here we're going to run start, and we're going to say, hey, it should be visible as our precondition, and then we're going to run update. And after we run update, we're checking that it's toggled to not be visible. And I don't actually know why I have this. I could probably take this off. This doesn't need to be there. And then the last one is update stops running when the total flashes are met. So again, we're starting things up. We're checking the precondition here, which is that it should be running. And then we run a series of updates that should get us to the point where total flashes met, or the total number of flashes have happened, and then we're just asserting that it's still that it's no longer running, that the flasher is basically turned off when the total number of flashes is reached. One thing I don't like about this test is it's not clear why there are 3 updates, and that's one of the things that I would like to clean up, but I feel like I need to understand how NUnit structures things a little bit better before I can do that. Just because, for example, you could say extract a method here that takes care of making sure that the total number of flashes are met, and there might be some nice way to do that with like a setup block or something. I'm just not familiar enough with how NUnit handles it to do that. So yeah, if I figure that out, maybe I'll follow up with another video about how to do that. And if you're an NUnit expert, please drop some comments and let me know how to approach that. But a couple things is just like high-level things I wanted to mention about this are one of the things that I try to do within any framework that I'm using is try to have as little code as possible married to that framework, because who knows, like one day you may want to change frameworks. You may just not want all that baggage of what the framework brings along and the classes you're inheriting from. So even from like a unit testing standpoint, the simpler the thing is that you're testing, the better off you're going to be, the less things you're going to have to test, the less chance there is that you're going to be potentially testing the framework instead of actually testing the code you're writing. And if you're using a good framework, the framework should be well tested, so you really shouldn't have to worry about, you should never really be writing tests for the framework. So one of the things that I was really trying to do here was make sure that this flasher was totally independent. I may only ever use it in this project, but just still just from like a testing standpoint, isolating it and encapsulating it was something I really wanted to do. And initially it wasn't that way. Initially this flasher did have to include Unity because I was basically passing in the sprite renderer, which is the thing that ultimately shows or doesn't show the sprite in Unity. And in order to include that, I had to add using Unity at the top so it knew what the sprite renderer was. But I kind of asked myself, like, do I really need to do this? If this thing really, if there's any way that this code doesn't have to have all that special knowledge about how Unity works, I wanted to separate it. So what I did was, instead of passing in the sprite renderer, I just changed it to essentially have a value that we could just check from the outside, which is this is visible property. So if we hop over to the hit reaction, you can see that this fixed update checks a couple of properties. So if the flasher is running, it's going to go into here. If it is, it's always going to run the update, and then here the render, whether the render is enabled or not, is just controlled by the value on the flasher for is visible. And this kept me from having to just pass in the whole sprite renderer and set the value within the flash class or flasher class. And I'll probably make this more generic. You'll notice I've called this flasher an effect, and the interface for that's really small. All it is it has is running property and is visible property, a start and an update. I could change is visible to effect value or something like that, and that would make it nice and generic. So I could have a flasher which has a value, and the sprite renderer could just use that value, and then I could have other effects that affect other values. So I don't know, maybe it's opacity or whatever. It doesn't really matter. But if I have an interface that's that generic, I could make a whole bunch of effects that all just behave kind of the same way, which would make it easier to swap effects in and out of different mono behavior or different game objects, I guess. But yeah, I think that's about it. Thanks for following along here. And like I said, I'm still a bit new to Unity, a bit new to C#, definitely new to NUnit and unit testing C#. So if you have any suggestions or comments, I'd love to hear those. So please drop those down below. And as always, you can jump in a comment, and I'll follow up on any comments. And then also you can find me on Twitter. Probably the easiest way to find me is at QuarterCrunch. I also, my professional, I guess, Twitter account is at DRafoff, but that's very difficult to spell. So I'll drop a link to both of those down below. But yeah, thanks for joining, and be posting more videos as I learn more about working on games in Unity. I'm hoping to do one pretty soon too on like the observer pattern or pub sub pattern, because that's something that's pretty useful for any kind of like UI updating you're doing, and just anyway, it's generally a pretty useful pattern. So yeah, check in for more videos on game development, and yeah, thanks again for joining.